Hello everyone, welcome to Civil Engineering and Stuff. And in today's video lecture, we will be doing certain numericals on the topic duty and delta. Okay, now I have already prepared a detailed lecture over the topics what duty means, what delta means, what is the relationship between duty and delta, what are the factors on which the duty and delta depends, and what are the different terminologies that through which we define the duty of the crop. So a detailed lecture about the duty and delta I have already prepared, and if you haven't watched that video, you can watch that video to brush up or get an in-depth understanding about the terms duty and delta. Okay, in this video lecture, we will be simply doing the numericals. All right, and through the numericals, we will be basically understanding the how the numericals are done, and at the same time, we will be revising the concept of duty and delta. All right. So before jumping to the numericals, let us just brush up our understanding over the terms duty and delta of the crop. Now, talking about the delta first, delta is defined as the total depth of water required by the crop to come to its maturity. Okay, this means that throughout the growth of the crop, so once we sow the crop is few centimeters high, then it grows, it starts to grow, and it attains some height, and then eventually it attains certain maturity, right? And during this time, certain amount of watering is done. So let's say when the crop was few centimeters high, let's say 10 mm of water was supplied, then we supplied 200 mm of water, then 600 mm of water was required, and then let's say 800 mm of water was required by the crop to fulfill its water requirement, right? This much amount of irrigation we have done. So the total quantity of water in terms of depth that we have supplied for the crop to come to its maturity, that is 10 mm plus 20 mm plus 6 mm plus 800 mm. So whatever be the value, that is what we call as the delta of the crop, right? The total depth of water that we have supplied, and delta is represented by the symbol like this. Okay, so this is your delta. Coming to duty, duty is defined as number of hectares of land irrigated for full growth of a given crop by supply of 1 meter cube per second of water continuously during base period B of the crop. Right? So this means that during the base period B, we are supplying the water at a constant discharge of 1 meter cube per second continuously. We are supplying this much amount the water at this discharge continuously during its base period. So whatever be the base period, 24 in 7, we are supplying the water at a constant discharge of 1 meter cube second. Once we do that, once we supply the water at a discharge of 1 meter cube per second, so whatever be the hectares of land that has been irrigated is what we call as the duty. This is what we call as the duty of the crop. And the unit, talking about the unit will be hectare per cubic. The unit is hectare per cubic. All right. So at this stage, this concept of base period, what base period means, this technical term should be very much clear to you. So your base period is defined as the time period between the first watering, the time period between the first watering and the last watering, the time period between the first watering and the last watering is what we call as the base period. Okay, and usually it is represented by days. All right. Now, talking about the relationship between duty and delta, your delta is equals to 8.64 B by D. This is the relationship between duty and delta. In this equation, is in meters, delta is in meters, duty will be in hectare per cubic, and the base period B will be in days. The base period B will be in days. Okay, this is the relationship between duty and delta. All right. Okay. All right. So this is just a brief revision of over the concept over that what duty and delta is and what is the relationship between duty and delta. Okay, so now let us jump over the numericals. Now, before we start solving the numericals, one thing I want to kind of request you that to make this lecture fruitful, keep with you calculator and notebook. Okay, you must have calculator and notebook with you, and as we progress with the question, you also should be solving the question side by side, right? So as and when we read the question, you can pause the video, try to solve the question by yourself, and then see is your answer is correct or not, or if I am doing calculation right or wrong. If I am doing any incorrect calculation, you should write these in the comment section. Okay, and if suppose you are not able to do any question, then at least you will get to know where the hindrance lies. Okay, where is that concept that you are not able to grasp, because of which you are not able to solve the question. Okay, so it is very important that is solved side by side. Okay, all right. So let's jump over the questions. So the first question that we have is that if rice requires about 10 centimeter depth of water at an average interval of about 10 days and the crop period of rice is 120 days, find the delta of the crop. Okay, this is the question. Right, so first thing is that you should know what the crop period is. Crop period is the time period between the sowing and harvesting of the crop is what we call as the crop period. Okay, first thing is that. All right. Now the question is that the rice requires 10 centimeter depth of water, and this water will need to be supplied every 10 days. Okay, so every 10 days we need to supply the rice crop 10 centimeter depth of water so that it can fulfill its water requirement and attain its full maturity, right? And the crop period is 120 days, and we have to find out the delta. Okay, okay. So now let's solve the question. Okay, now you see we have to find out the delta of the crop. What we have to find? We have to find out the delta of the crop. Now delta, as we have seen, that delta is the depth of water, right? The total depth of water that will be supplied to the crop to attain its full maturity. To attain its full maturity. So definitely here the crop period means that up till its harvesting, we will be supplying the water every 10 days, and each time we are supplying the water, we are going to supply the water up to 10 centimeter depth. Okay, so delta means the total quantity or total depth of water that we are supplied to attain the maturity. Okay, so first of all, if we are supplying 10 centimeter of water every 10 days, so how much was the watering interval of the crop? Okay, so how we will find the number of times number of times the watering was done. How we will find number of times the watering was done? It will be 120 divided by 10. 120 divided by 10 days. Okay, so this will be 12 numbers. Okay, so 12 numbers of time we are going to do the watering, because the crop period is 120 days, and during this 120 days we are supplying the water. How we are supplying the water? We are supplying the water every 10 days, and each time we are supplying 10 centimeter depth of water. Okay, so as delta is the total depth of water that we have supplied, so the delta will be total depth of water. So we are watering the crop 12 times. Each time we are supplying 10 centimeters. So what will be the total quantity of water or the total depth of water, that is delta? That will be 12 into 10 equals to 120 centimeters. Okay, this will be the answer. Simple. Okay, this will be the answer. Okay, I hope this question is clear to you. If suppose you are having any doubt or any question, you can always ask in the comment section. Okay, now let's move on to the second question. Question number two is question number two is if wheat requires about 7.5 centimeter of water after every 28 days and base period for wheat is 140 days, we have to find out the delta of the wheat crop. We have to find out the delta of the wheat crop. Solve it. Try to solve it by yourself and see if have you done correctly. Okay, so what will be the solution? So if you see, the language of this question is exactly similar to the language that we of the question that we had done just now. The only difference is instead of crop period, we have been given base period. Okay. Now base period is what is base period? Base period is the time period between the first watering, and the last watering. Okay, time period between the first watering and the last watering is what we call as the base period, and the time period between the sowing to the harvesting is what we call as the crop period. So if you see in this question, we have been told that base period is 140 days. So the total quantity of water that will be supplied will be within this range only, between the first watering and the last watering. And after the last watering, then the next time there is no water will be supplied, and eventually harvesting will be done. Okay, so this is the net quantity of water that is supplied. Okay, so more or less things remains the same. Okay, so so solving the question, first of all, in a similar way, the number of times watering was done, the number of times watering was done. How we will find? We will find by like the base period was 140 days, and water will be need to be supplied after every 28 days. So the number of times watering will be done will be 140 divided by 28. That will come out to be how much? That will come out to be 5 times. Okay, 5 times. Each time, how much quantity of water we are supplying? We are supplying 7.5 centimeter of water. So total depth of water that will be supplied, that will be supplied, total depth of water that will be supplied during the base period, during the during the base period will be how much? It will be 5 multiplied by 7.5 centimeters. The answer will be 37.5 centimeter. 37.5 centimeter. This will be your answer. Got it? All right. I hope the question is clear to you. Okay. Moving to the next question. Next question is we have to find out the delta of the crop when the duty is 864 hectare per cubic on the field and the base period of the crop is 120 days. What is the delta of the crop when the duty is 864 hectare per cubic on the field and the base period is 120 days? Straightforward question. Okay, it is nothing but a straightforward question. We know the relationship between duty and delta is equals to 8.64 B by D. Correct? So delta will be 8.64. What is the base period value? Base period value is given as 120 days. 120 divided by duty. Duty value is 864 hectare per cubic. 864 hectare per cubic. So solving it, the duty will come out to be 1.2. Unit will be meters. So the delta that will come out to be will be 1.2 meters. This will be the answer. Okay, straightforward question. Moving to the next question. Next question is given the base period is 100 days and the duty of the canal is 1000 hectare per cubic, find out the depth of water. The depth of water will be what? Depth of water will be what? Hmm. So I hope you understand the trick part on in this question. The question is nothing but a twist of words. So you see, it is just saying find out the depth of water. And we know the total depth of water is nothing but the delta, nothing but the delta of the crop. Correct? The total depth of water is nothing but the delta. Just a trick twist of words that is in this question and nothing else. Okay. So solving it, we know that delta is equals to 8.64 B by D. Okay, so delta is 8.64 B. What is the value of B? B is 100 days. It will be 100 divided by what is the value of duty? The value of duty is 1000. The value of duty is 1000 hectare per cubic. Okay, so solving it, the value comes out to be 0.864 meters. Okay, 0.864 meter or 86.4 centimeter. Clear? So this is the answer. Got it? This is the depth of water that will be there. Okay, just the twist of word. Moving to the next question. The next question is, if the depth is 8.64 centimeter on the field over a base period of 10 days, what will be the duty? Now in this question, we have been asked duty, and up till now we were finding out the delta. This time we are going to find out the duty. Okay, so this time we are going to find out the duty. So solve it. See if you are getting the correct answer. What is the formula? Delta is equals to 8.64 B by D. Now, the only thing that you have to be very careful about is the units. The question is very simple, but what you have to be careful about is the units. If you see here, the depth is given in centimeters. The depth here is given in centimeters. And we have discussed that in this formula, the delta is in what unit? It is in meters. Okay, so we have to simply convert this centimeter into meters and everything is fine. Okay, so 8.64 into 10 to the power minus 2 is equals to 8.64. Give me the B value. B is 10 divided by duty. So D will be 8.64 into 10 divided by 8.64 into 10 to the power minus 2. Alright, so we will have the duty equals to 1000. What is the unit? 1000 hectare per cubic. 1000 hectare per cubic. This is the answer. Okay, alright. Simple. The only twist was we have to be careful about units. Okay, be careful about this. All right. Okay, let's move on to another question. Now, the question is, what is the question? The question is, transplantation of rice requires 10 days and total depth of water required during transplantation is 48 centimeter. During transplantation, there is effective rainfall of 8 centimeter. What is the duty of irrigation water? This is a GATE 2013 question, and we have been given these four options. Okay, now pause the video, try to do it by yourself, and once you are done, then you can resume watching the video. Okay, all right. Now you see the question is what? It is fairly simple. We have to find out the duty. We have been given the what? We have been given the base period. We have been given the total depth of water required. That is 48 centimeter. Correct? The only trick here is that we have been given the effective rainfall. So to successfully do the question, you must understand effective, what does this effective rainfall means. Okay, what does this effective rainfall means? So what does this effective rainfall means? Effective rainfall is that part of the rainfall, the that part of the rainfall that fulfills the water requirement of the crop. Simple. To simply put, it is the that part of the rainwater that fulfills the water requirement of the crop. Okay. To further elaborate on this, you see, whenever the rain falls, right? Whenever the rain falls, we have, let's say, this is a beautiful plant. Okay. So definitely this plant has certain water requirement. Okay. And as and when rainfall happens, part of the rainwater is lost to runoff, right? Part of the water may be lost to evaporation. Part of the water may seep down and meet the groundwater table. Okay. Now, out of the total quantity of rainfall that has happened, the part of the rainwater that this plant will use to fulfill its water requirement is what we call as the effective rainfall. Okay, so effective rainfall is that quantity of rainwater that the plant has used to fulfill its water requirement. Simple. Okay, now you see here in this question we have been given the data regarding the effective rainfall, and the effective rainfall, it is saying that effective rainfall is 8 centimeter. So what does this mean is that the total depth of water required during transplantation was 48 centimeters. This was the total water requirement of the rice crop. This was the total water requirement. Then during this time, 8 centimeter of effective rainfall happens. Right? So this means that out of 48 centimeter, 8 centimeter was fulfilled through natural rain water that we are calling as effective rainfall. Alright. So so now, as and when we are going to do irrigation, and we know irrigation is artificial application of water. So definitely we are going to fulfill how much quantity of water? We are going to fulfill what will be the net quantity of water required? The net quantity of net quantity of irrigation required. What will be the net quantity of irrigation required? It will be the overall water requirement minus the effective rainfall. So that will be 40 centimeter. All right. So your irrigation is what? Irrigation means artificial application of water to fulfill the water requirement of crop. Right. This is what the basic definition of irrigation is. And effective rainfall is what? Effective rainfall is that part of the rainfall that fulfills certain water requirement of the crop. Okay. So now the irrigation that we are going to do, we are not going to do to fulfill 48 centimeter. We are going to do to fulfill this 40 centimeter. Clear? Simple. So if this concept is clear to you, then this question is very easy. Okay, this question becomes very easy. So now the net quantity of irrigation that is required will be 48 centimeters. Then simply putting in the formula delta is equals to 8.64 B by D. We have to find out the duty. So duty will be equals to 8.64 B. B is given as 10 days. B is given as 10 days. And duty is what? What is the duty value? Duty value is what? It is 40 centimeter. That is we are going to go for the irrigation. Okay. So solve it. What will the value that will come out? The value will be 216 hectare per cubic. Alright, that will be option number B. Okay, I hope the question, concept of the question and the question itself is clear now. Okay, again, if you are having any doubt, you can always ask in the comment section. If any calculation mistake is there, again, point out in the comment section. Okay, moving on to the next question. Next question is, an agricultural land of 437 hectare is to be irrigated for particular crop. The base period of the crop is 90 days. The total depth of water required by the crop is 105 centimeters. If a rainfall of 15 centimeters occurs during the base period, the duty of the irrigation water is what? What will be the duty of irrigation water? So we have been given one, two, three, four options. Okay, right? So solve it. See if you're getting the correct answer. All right. So let's solve this question. Now you see in this question we have been given that we rainfall of 15 centimeters occurs, and just now we have discussed rainfall is different from effective rainfall. Okay, so what we can do is we can first of all let's try with that none of this water is being utilized by the crop to fulfill its water requirement. That is the depth of water, which is 105 centimeter. None of this is being utilized, or none of this is being used from this 15 centimeter. We'll try and solve this question. Okay, like that. Okay, so in this scenario, the delta is equals to 8.64 B by D. So delta given to us is 105. Please mind the units. 105 into 10 to the power minus 2. 8.64 B. What is the B? 90 days. And we have to find out the what? We have to find out the duty. We have to find out the duty. So if we solve like this, then D will be equals to 8.64 into 90 divided by 105 into 100. Okay, so solve it and tell me what is the answer. What is the answer of this? I hope you are solving as we move along. Okay, so the answer here will come out to be 700, oh sorry, 740.571 hectare per cubic. That will be the answer if we solve like this. So right now our nearest option is 741, C part, right? Our nearest option is C. That is not the exact one. Okay, so in this scenario, when the answer is not exact, let us consider another scenario, scenario 2. Okay, let us consider scenario 2. Let us consider scenario number 2, in which in this scenario this rainfall of 15 centimeter is, we are going to assume this rainfall to be effective rainfall. Okay, in this scenario we are assuming this rainfall to be effective rainfall, okay, of 15 centimeters. Now, if we consider this rainfall to be effective rainfall of 15 centimeters, so definitely what will be the total depth of water required through irrigation? So the water required will be what? Or the depth of water required will be what? 105 minus 15. 100, it will be 105 minus 15. So the answer will be 90 centimeter. This is the depth of water required, right? This is the depth of water required. All right. And then, like, the question becomes more, is like just like the one that we had done previously, right? Into 90 divided by what is the delta value? 90 into 10 to the power minus 2. Okay. So doing so, we cancel this one. It comes out to be 864 hectare per cubic. And if you see, we have the option here, right? We have the option 864 hectare per cubic. All right. So the answer here, the answer will be what? Answer will be D. So this is a learning for you that in these objective type, because in objective type the answers are limited, right? We have been given certain options and we have to choose from this option. Okay. So in this, what the question setter has done, he has again played a trick. Instead of calling it as an effective rainfall, he has simply called it as rainfall and given the value of rainfall. Now, definitely the water that is being the part of the rainwater that is being utilized is what we refer to as effective rainfall. Okay, and but here in this scenario, he has given one option that is nearest, while other option that is exact. Okay, so in this case, when if in your exam you are not getting the out of the given options, right? I'm talking when we are given the options, then do try some different techniques also. Okay, because we are not getting the exact answer in by considering this scenario one, right? By neglecting this part, we are not getting the exact answer, right? However, if we consider this as an effective info, we are getting the exact answer. Now, if this question would have been subjective in nature, okay, if this question would have been subjective in nature, then definitely you would have written a statement that this rainfall, since it's a rainfall of 15 centimeter, so considering that no part of the water has been utilized or has contributed towards the plant growth, hence irrigation being done for 100, the depth of water that will be supplied will be 105 centimeter. You have to write that statement. Okay, then you have to move forward. Clear? Okay, I hope the concept of this question is clear to you and this how to approach such kind of questions is clear to you. Okay, okay. Let's do another gate question. And I presume this is the last question. Yes. Okay. So the question is the culturable command area for distributary channel is 2000 hectares. Wheat is grown in entire area and intensity of irrigation is 50%. The core period for wheat is 30 days and the core watering depth is 120 mm. The outlet discharge for distributive will be what? And we have been given four options. Okay. So again, pause the video, try to do the question by yourself, and once done, you can resume watching the video. Okay. All right. So let's solve the question. So before solving the question, few terminologies should be clear to you. The first terminology is that what is culturable command area. Okay, this terminology should be clear to you. Then what do we mean by this intensity of irrigation? This terminology should be clear to you. Then what is core period and what is core watering depth or core water depth? These terminologies should be clear to you. Okay, because as and when this terminology is clear, the question becomes very easy. Okay, so let's talk about first of all what is culturable command area that we refer to as CCA, culturable command area. Culturable command area, it is your culturable command area. It is this that portion. Culturable command area is that portion of gross command area where the cultivation will be done. Okay, where the cultivation will be done. First thing is that, right? So like you have the whole full area and that you have taken into consideration for irrigation that is called as GCA, and out of GCA part maybe some habitat area, part maybe some like some lake or some other geographical features, and then we have a certain portion where actually this cultivation is being done. So this out of the GCA, the part where the cultivation is being done is what we call as the CCA value, right? And out of this CCA where the irrigation is proposed, out of this cultural command area, the irrigation actually will be done. Actually will be done is what we call as the intensity of irrigation. This is what we call as the intensity of irrigation. Okay, so out of this area, out of this full area, which was where the cultivation will happen, right? Out of this area, the part of this where the irrigation will be done, right? The part where irrigation will be done in a particular season or a year, that is what we call as the intensity of irrigation. Because let's say in summer some crop is grown and part of the land may be kept barren for replenishment purpose or XYZ reason, then then in the next season this part cultivation is done and this part is left barren, right? So that is that portion of CCA where the irrigation is proposed is what we call as the intensity of irrigation. Clear? Then core period and core watering is the terminology that is defined when the crop is only few centimeter high. Few centimeter high. So when the crop is few centimeter high, the total depth of water that is supplied is what we call as the core watering depth, and the time period for which the core watering depth is done is what we call as the core period. Okay, this is just a revision towards the basic concept. Correct? Now let's move on to the question. Okay, let's move to the question. Now the question is that the cultivable command area is 2000 hectares. Intensity of irrigation is 50%. All right. So I hope now you can appreciate what the question means. The question means that your area CCA value is 2000 hectares. However, the irrigation will be done only on the 50% of the land. The irrigation will be done in over the 50% of the land, right? And during this time, the time period for watering will be for 30 days, and the depth of water that will be supplied will be the total depth of water supplied during these 30 days will be 120 mm. Okay, and what we have to find out? We have to find out the discharge value. Okay, I hope now you can appreciate this question. Okay, so let's solve it. So the ultimate thing that you have to find out, what you have to find out? You have to find out the discharge value. What you have to find out you have to find out what is the discharge. Hmm. How should we approach the question? Think about it. Now, first of all, let's go step by step. The cultivable command area is 2000 hectares. The density of irrigation is 50%. So, the irrigation, the the actual area, actual area where the irrigation, the actual area where the irrigation will be what? It will be 50% of CCA value. That is 50% of 2000 hectares. 50% of 2000 hectares. So the value will come out to be 1000 hectare. Okay, so first thing is that basically we are going to be doing irrigation for 1000 hectares. Now you see, uh, we have been given core period that is the base period. We can say it's kind of a base period, no, that the total days in which we are supplying, and then this is is with respect to the question is what we can say is the delta value, because we can see 120 centimeters, right? Now you see we have been given B, we have been given delta. So since we have no clue, let's find out the duty. Hmm? Okay, so we will find out what? We will find out the duty. So duty will be equals to 8.64 into B. B is what? 30. B is what? 30. And delta that is given to is 120 into 10 to the power minus 3, because it is in mm. Please remember the units, the game of units. Okay, so if you see 8.64 into 30 divided by 120 to 1000. So the value will come out to be 2160. What is the unit of duty in this case? Hectare per cubic. It will come out to be 1260 hectare per cubic. Hmm. Huh. So now from here, what you can assess? You can assess one thing, that this is what? Cubic. This is discharge. This is what? Hectares of land. That is looking at the definition of duty. What is the definition of duty? The definition of duty is the number of hectares of land irrigated when you're supplying water at the rate of 1 meter cube second for the base period B. Here, this means that if in this base period, if in this period of 30 days, if you're supplying the water at the rate of 1 meter cube per second, we will be able to irrigate 2160 hectares of land. Okay, so by simply using the unitary method, for 2160 hectares of land can be irrigated by 1 meter cube per second of discharge. In this 30 days, this 2160 hectares of land can be irrigated by 1 meter cube, right? So 1000 of hectares of land will be irrigated by how much? It will be irrigated by 1000 divided by 2160. Okay, so the answer will come out to be 4.63 meter cube per second. That will be the discharge. Which is the option? Option number C. Option number C will be the answer. Okay, got it. All right. So this is nothing but the definition of duty, and from the definition of duty, we have simply used the unitary method. All right. So these are the questions that are there for duty and delta. I hope through these questions, the concept of duty and delta is much more clear to you, and I have tried to cover certain variety of questions. In the upcoming lectures also I will include more duty and delta question along with some other topics. Okay, so do watch those videos. And for this video, if you have any doubt or any question, do write in the comment section. If you have liked the video, if you have found the video to be useful, make sure you like the video, you comment your suggestions in the comment section, and definitely if you find this video to be useful, then do subscribe to the channel. Okay, thank you for watching. Have a nice day.